Application security is hard when security is separated from your DevOps workflow. Security has traditionally been the final hurdle in the development lifecycle. Iterative development workflows can make security a release bottleneck. With GitLab, security is built into the CI/CD process. Every code commit is automatically scanned for security vulnerabilities in your code and its dependencies. Results are delivered to the developer in their native workflow for rapid remediation. Learn how GitLab enables DevSecOps. Visit securityweekly.com/GitLab for a 30-day free trial. Cloud-native development presents new challenges for security teams. Ephemeral workloads are scattered across services, and it's hard to identify resources, monitor configurations, and ensure compliance. Prisma Cloud by Palo Alto Networks is a comprehensive cloud-native security platform delivering full-stack protection for multi- and hybrid cloud environments. It provides deep visibility, threat detection, and data security, as well as protection for hosts, containers, and serverless while enforcing policy guardrails. Visit securityweekly.com/Prisma Cloud to gain control over your cloud security. We're proud to announce CISO Stories, a new podcast series in partnership with Cybersecurity Collaborative and Cyber Reason. CISO Stories features the candid perspectives and experiences of frontline senior security executives and dives deep into timely security topics. CISO Stories is hosted by Todd Fitzgerald, VP of Cybersecurity Strategy at Cybersecurity Collaborative, and Sam Curry, Chief Product and Security Officer at Cyber Reason. Listen weekly as they speak with extraordinary CISOs by visiting securityweekly.com/CSP.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by John Kinsella. Do you want to stay in the loop on all things Security Weekly? Visit securityweekly.com/subscribe to subscribe on your favorite podcast catcher or our YouTube channel. Sign up for our mailing list and to join our Discord server, where we have lots of fun chats. Our next live webcast will be on April 29th at 11 a.m. Eastern, where you will learn how to prepare for modern ransomware attacks. Visit securityweekly.com/webcasts to register now. If you missed any of our previous recorded webcasts or technical trainings, they're available for your viewing pleasure at securityweekly.com/on-demand. And that brings us to quite a busy application security news week, I think. We've got a lot of articles today, and there was even, speaking of supply chains, or we're about to speak about supply chains, even PHP I was reading about this morning had some malicious code commits that were essentially some backdoors, and they've moved from their Git repo into GitHub to handle that. And I had originally picked out another article that was referencing SolarWinds, and just not to talk about SolarWinds specifically, but more about continue to riff on that, about what does it actually mean to change your, to improve your SDLC to prevent these types of malicious code being introduced into your systems. And so real quickly, this article has, it's a bit light on content, but it does link to some discussions that SolarWinds is having. And they basically pull out a couple things that they're doing that I think are templates that other companies can think about, figure out how to adapt for themselves. That template is move to a cloud identity. So what's your single source of truth, if you will, for your identity of users as well as systems? Of course, having MFA deployed everywhere, ideally token-based, something that is FIDO supported, and doing risk, as they describe it, risk-based authentication authorization, which is essentially a zero trust type of security model. And I think one other aspect they were talking about as part of that too is that moving to the cloud also means they could spin up just-in-time build systems, which is both in the aspect of you have infrastructure as code that could describe what your build system is ostensibly supposed to look like every time it's spun up to build and deploy new code, as well as it diminishes the capability of persistence from attackers. So attackers aren't going to be able to, the utility of persistence on a build system that's only spun up for build A but not for build B is going to be much harder to pull off a significant attack that might be like that SolarWinds attack. So a couple lessons to be learned there, a couple things that I think could be generalized and adopted from other organizations. But I think that is a horse that I've possibly beaten to death enough. I don't know, John, any additional kicks you want to get in there, or should we move on?
I'm curious. So let's see. Talking about articles we're not covering, I heard last week that the SMS attacks we talked about previously that were allowed, the marketing company allowed to mirror your SMSs, to use the phrase. Apparently, the telcos have stopped that. So maybe, for another next week or two, SMS 2FA isn't too bad, but we know they're going to come up with something else. So still, as you said, tokens are your friend, or at least soft tokens. So here's my question on this one. Is creating parallel build systems, and he's saying like 2 or 3, is that actually going to give you a security gain, or is that sort of, to use the phrase, security for security's sake? Is that actually going to make a difference? Think about, as your code base gets more complex, and the way you do your testing, your builds, your releases, all this stuff, now you want to duplicate that across 2 or 3 different systems. That sounds it definitely is a lot of work, but what's the value behind that? That's what I'd be curious to see.
I did scratch my head a little bit at that, because it sounds like we want to triangulate 3 different build processes and make sure that each of them reproduces the same artifact with the same signature, or at least signatures that prove integrity throughout the process, and the same hash that says they were identical. But it does, I love to quote my movies, old movies for that matter. It does sound like there's a quote from Contact. It's something along the lines of, "Why not build 2 at twice the cost?" And I think that kind of speaks to what you're getting at. Is this just security to have a lot of parallel builds to make it harder for attackers? But is that the right is that the right cost transfer to attackers, or are you subsuming a lot of that cost yourself just by that complexity? So a little bit of a head scratcher, and I couldn't find any more details on what that architecture actually was supposed to mean, and how what the security properties and choices went into that architecture. But as we learn more, we'll figure that out, and maybe come back here and see if that's something to emulate, or something to continue to question and say, what threat model is this addressing, and are we just trying to address the attack that we know about, in that spirit of don't do this, what we were talking about with Andrew last session, or is in the spirit of there is a strength here in the design of the system that actually gives us some additional beneficial properties that don't come at an exorbitant cost. Other things that are exorbitant costs, one would be talking about not so much the moving on from supply chains, but I thought was pretty interesting was the TikTok and Douyin, 2 applications that Citizen Lab, a great organization out of academics out of Canada, who did a technical security and privacy analysis of these applications. And one, it's I think of interest if you were following TikTok in particular. You can learn about just what could you learn from reverse engineering that. But I think too, as just a kind of reference and as kind of a way to model, how do you reverse engineer and present and communicate an analysis of an application? I think that's a good template to emulate. And it ties in, I think, very well to the last segment we were having, the discussion we were having with Andrew about there's a good skill in communicating. We found these security problems, or for that matter, we didn't find security problems, but here is what we did to look at. Here was a methodology we followed. And I thought this was a pretty good write-up. And nothing too surprising, I think, other than a lot of bots want to use TikTok, just as probably a lot of bots want to use Facebook, Twitter, etc., for abusive or user-friendly use cases. And they have, in this case, another thing that stood out was TikTok had some signatures that were using to essentially sign requests, making it more difficult to spoof and impersonate legitimate traffic. So nothing too exciting there, other than a great reference of tools and technique for reverse engineering an Android app, and a good example of documentation, a way of communicating findings.
It's a good write-up, yeah. I thought you were just putting this in here to get all the kids to watch ASW, but okay.
We got to do an ASW dance to get on TikTok properly. So we're still working on that.
I had TikTok installed for a week or 2, and it's a lot of fun, at least to watch. I'm sure to do the dances too. But as a security guy, I can't have it on my phone. And this is sort of this is a good write-up. 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 This is a good write I think for me, it was the second bullet in the summary. While these things, and I had never heard of Douyin actually, but while these things, because I have gray hair, these things do not appear to be explicit, overly malicious behavior. That's compared to malware. That's not a ringing endorsement for something I want on my phone. Unfortunately. But what's interesting, you said it's not, there's nothing sexy going on here. It is good. It is how many times can we say it is a good write-up? And I think it's good for people to think about this as we talk about frameworks, we talk about different ways you can go through these tests. Here's sort of, from an educational point of view, it's interesting to look at this and think about, okay, how would I use this methodology on my app or applications? The thought, though, which is interesting to me, is while these guys might not be, application security isn't always something to prevent attackers coming towards you, right? Sometimes it can be used, I don't want sort of offensively, from the point of view of you want to make sure that your system is tight enough that someone else can't do things which would give you a bad name. So I think that's sort of what they're doing, and from that point of view, that's it's sort of not quite militarizing it, but it's are weaponizing it. But it's still they're taking care of number one. So I think that's sort of interesting how they're doing it.
It's interesting how they're doing it, and it speaks to there's an underlying theme that came out of the first segment with Andrew talking about the OWASP top 10 of the distinction between addressing technical security issues, flaws that you might find in the OWASP top 10, so to speak. But there's also an aspect of data handling. Who owns the encryption keys? How is data encrypted? When and where can it be decrypted? And just looking at a client-side technical analysis of TikTok or something like that won't necessarily reveal how that might be misused or address some of the what might be other privacy or censorship concerns. So I think that there's a good angle there to mention, here's how we position, what can we discover about this application? And so let's actually have a good evidence-based discussion around the technical aspects. Is it collecting all of the data that we think it's collecting, or is it just, did someone just kind of mistakenly misunderstand some decompiled APKs? But also point out what are the threat models we're concerned about. And the threat models aren't necessarily most concerned about, are there third-party bots using this? That's probably more concern for ByteDance and protecting the integrity of their systems or rate limiting access to it. It's not so much about, is this hard to reverse engineer? It's more about what data is being collected, how it's being misused. So I think that is one of the things I'd also highlight as part of this conversation, the meta conversation I think we're having around top 10 lists, security, and product safety that we'll also get to in Slack, but maybe I want to save that for a little bit at the end because we have some other technical items here to hit on. So trying not to monologue too much like a movie villain, I will hit another example of just communication. And this was analyzing attacks taking advantage of Exchange server vulnerabilities. Now, quite honestly, I don't want to get to harp on this too much because I don't know that many people out there are running Exchange servers, but if you have been, please just migrate to the cloud. Just as PHP is learning this morning, you don't need to run your own Git server. You don't need to run your own mail server in this day and age. Hosted providers can just at the very least take care of patching for you. But the reason this article stood out to me is that it was referencing the MITRE ATT&CK framework. So I thought this was a really good framework as a lingua franca of how do we talk about ways that, in this case, Kubernetes environments are attacked. And I thought that was really neat, as well as this was showing just some examples of post-exploitation within environments. And so it's sort of the aspect of, don't worry if you are not running an Exchange environment, but do a pre-mortem. What would a post-exploitation activity look like on your environment? Could someone write to an arbitrary file? Could someone launch, an arbitrary command? Are you watching for syscalls? Are you blocking syscalls? Are you monitoring, user access? These types of things. So this is more of an exercise in pre-mortem, as I would like to do it there. And with that, I think I'm getting pulled off stage, and I need to hand this over to John to talk for a minute.
Oh no, I've got nothing to say. Go ahead. No, I'm just kidding. It took me. Hell, man, probably 6 or 12 months, if not longer, after attack came out, to just in general the attack framework, before I sat down and said, why is everyone talking about attack? So I suspect I'm not the only one in that boat. This Kubernetes version came out, the original version last year, and there's an update on it. I think they've got a container one too. What's interesting about attack to me is that they're doing these based off what they're seeing in the wild. So they'll actually, they've got a pretty decent partnership. Obviously, MITRE's been around for a while, and obviously Microsoft and everyone helping with this. So those guys go out to their friends and family and say, hey, give me some of the examples of what your folks are seeing come in real world. So that gives us a lot of heft, a lot of, if you go back internally in your company and you're talking, you need to get buy-off from management or executives to be able to say, hey, look, we need to spend time or budget improving our security because of these things, and this is what people are, not just we're thinking is theoretical, this is what people are actually seeing out in the wild. So the list itself, I don't think anything was too shocking to me. I mean, if you're running a Kubernetes dashboard, that doesn't seem like something people do. Well, people should be doing in production. Should be. But so the overall list is interesting, and I guess they depreciated that. But it's definitely worth, if you're doing containery stuff, and again, as we said, don't be running your own exchange. Don't run your own Kubernetes unless you've got a really good reason. But even if you do a hosted Kubernetes service from one of these providers, there's still going to be things you have to at least be aware of, if not actually harden and tighten and do things. So this is well, there's a lot covered on the subject, and we're yapping about it a lot here. It's a pretty simple thing to sort of take a glance over and get a read through, at least the table, and sort of figure out what are people thinking about, and then from there see what catches your attention and drill down into that.
Yeah, I think the one other thing I'll add to this too is that there is the aspect of are you working on the Kubernetes ecosystem, and looking at the attack matrix, can you can you kill off a bug class? And so there was an aside here in the article that's saying, as of version 3, Helm has changed its operations, so now by default, it's gotten rid of one of those small blocks within the attack framework. So that's a good thing, because now we actually have, drumroll please, a secure default, and that's a good thing. And I think that's much better as a callback to our great conversation with Andrew, is rather than say, well, don't run your Access Kubernetes dashboard, don't do this other thing. Instead, it's like, oh, just roll out Helm, and you now actually don't need to go and now reconfigure it to be secure. It just came secure out of the box. And I think that's a smart thing to look towards.
One more on that, since you mentioned secure by default, the SIG security guys on the Kubernetes side, they really care about that a lot. They're putting a lot of effort into that. I've been sort of sitting on the side watching some of the discussions there. The pod security policy replacement has gone into an enhancement protocol, so that's making progress to actually have secure default security policies on some of these things, or controls around those. But frequently, one of the things which keeps coming up around a lot of the Kubernetes aspects, at least in core Kubernetes, is making sure that what's there by default doesn't allow someone to shoot themselves in the foot. So lots of progress being made there, but still, once again, don't just trust other people. Be familiar with this.
So let's shift now to some other fun things. John, you found a fun article about one of my favorite topics, parsing. This was a little bit of a kind of a neat, surprising error. So what happened here with net masks and NPM libraries?
Yeah. So I don't know how well known this is. I don't think it is. I mean, I've been doing networking for, I don't want to count how many years, too many years. I didn't realize that, at least for most modern parsers, and by modern I think it's probably always been this way, if you take an IP address, 127.0.0.1, and you put a 0 in front of that, that gets parsed as a completely different IP. So that's now octal format. For C coders out there, they'll recognize that. But that means that 127.0.0.1, if you make that 0.127.0.0.1 gets turned into, in decimal, that's 87.0.0.1. So totally different IP address. And it turns out most of the resolvers out there are aware of this, unlike me, and they've coded it correctly. There's a library for Node, the NPM system. There's a library called netmask that, like me, didn't know this. So what the problem with this is if you're able to submit a request into a Node.js system, and it's doing some amount of parsing on there. And the fun one is if you've submitted, what's the other IP? It's down here. 0177.0.0.01. That just looks like some IP address on the internet, right? Just scrape off the one and go ahead and process it as usual. It turns out that's octal for localhost 127.0.0.1. Long story short, what that means, what this little simple parsing issue of not understanding how to convert that from octal to decimal means that you could probably do something like server-side request forgery. You could, if that IP address is being used for, maybe to download an image off the internet, and you can now have a way to say, hey, actually connect to the local host. Things get interesting at that point. So, we trust these libraries because individually we're not going to figure out all this stuff by ourselves, but it's still, something for, there's what seems like super simple IP address parsing, leaving v6 out of it, just talking about v4. There's always these little edge cases and gotchas that you got to be aware of. So I thought this was interesting from that point of view.
Definitely a fun one. And I know for those of you out there who've gotten into the weeds of cross-site scripting attacks, there's also a long history of URL obfuscation and throwing octal addresses as well as dotless addresses into XSS payloads just to see what browsers support them, how they interpret them and parse them. So definitely the lesson of normalize your IP addresses and then do your security testing or security validation on them. And look out for SSRF, especially for cloud environments. Also look out for undocumented x86 commands. So we have, I think, a pair of articles that might go together well. I was looking at something that was looking at Intel processor trace related to fuzzing. But John, you were diving into some really crazy microcode. And I'm going to throw this one back over to you to start us off with, because it's definitely getting some move bites in there.
Yeah, so this is a fun one, and I didn't realize we were sort of, our brains were sort of thinking parallel the last week or so. Story off Hackaday, someone's been, it's so, fuzzing is interesting from, let's sort of set this up a little bit. Fuzzing from a CPU instruction set is sort of, that can be a rewarding process for the right individual. If you're able to find an undocumented microcode in there or an undocumented CPU instruction, has it been tested? Right. So you go through, once you find something undocumented, it's like, okay, can I use it to my advantage? Is this untested or maybe not tested enough? So it's not, might have a higher chance of bugs, all sorts of different things in there. Or maybe just, you suddenly have God access on a CPU. But with modern CPUs, this becomes more and more difficult because the old space we used to scan is been pretty well tested. So now you have to go and try different things in a different space in there. There's a greater chance of crashing the CPU, which means you have to start all over again or freezing things, so it becomes more and more difficult to go after some of these things. And what some folks have figured out is that you can use speculative execution to go down this path. So speculative execution, is great in theory. All this pipelining and stuff we have in CPUs nowadays to try and speed things up. But what we're seeing is there's been all sorts of security edge cases around this one. So this is another one where basically it might not be your main execution path you're going down, but you can actually, as you know what you're doing with your machine language coding, you can leave off an if branch, have it go and try a CPU instruction which doesn't exist. So without actually fully running that branch, you can get a sense for if it's going to crash or not. Which allows you to, obviously this is super complex and not something you just do on a weekend, but at the same time, it allows you to understand what's happening in that space if you're doing this in a much easier, more efficient way. So for some folks out there, that's hugely powerful. But it's just, to me, it was interesting, one, the actual use of speculative execution, and then that someone figured out how to do this. I thought that was sort of the fun part around this. Probably not going to be too useful on the day job, but maybe it is.
Yeah, I don't know that. Yeah, it's not going to be showing up in my daily work, but it's always fun to read about, and especially just the aspects of, is this what kind of side channel might this set up? Whether it's timing, leaking bits of data, leaking data 1 bit at a time, and if that data is coming out of a secure enclave and it becomes you're getting key material, that could be pretty consequential. So definitely a potential for fruitful research from an attacker's perspective, in addition to just good educational. For those of you who want to get down into the very deep innards of chips. And that, I think, is a nice tie-in with this other article from Trail of Bits that was talking about how their coverage guided fuzzing with Honeybee, open source fuzzer, and using the Intel processor trace. And essentially, this was a really, again, a nice write-up, really well written. That's giving some engineering insight into the process of saying, we want to improve how fast, the performance of doing fuzzing. There is a great processor capability that could help us here, but at first glance, it looks like there's a significant overhead. But what was really neat is that the intern here, she did some great work on figuring out how to take advantage of this Intel processor trace, which basically just says it can now demonstrate here is using Honeybee to fuzz a library and do it efficiently, even if you don't have source to help drive coverage of it. You're able to trace through exactly what was essentially the control flow of what the application was going through. And the point was made here is that now it's very fast. Using Honeybee is very fast for open source projects like, specifically being called out, libpcap, libpng, and libjpeg turbo, and especially those last two as image frameworks, image libraries that are quite common, often used, very prone to vulnerabilities because this is where user-generated content comes from. A lot of images, whether you're sharing those images on TikTok or Slack, Discord channel right now, or what have you. Those are great attack vectors and, of course, great things to fuzz. So really neat research, really great write-up. And I'll just also comment, too, that Trail of Bits on their GitHub repo not only has this write-up for Honeybee, but they also have a publications repo that has a lot of great background and other research that they've done on various topics. So good reading material for you if you want to just learn about some more areas of application security.
Yeah, this stuff is it's a fun space. I've been playing with Fuzzing, actually FuzzBuzz, since they were on the show. I've been working with them over the last month or two, looking at how would that benefit us? How would it benefit us? What can we find? So it's been an interesting process to actually go through this with a modern tool. So I think something like this again. Are we going to use this in our day job? Well, it depends. If you're using a commercial fuzzer, hopefully they'll use it in their day job. As you mentioned, the points of going through some of those content libraries is very helpful for all of us. I'm struggling with right now with some of these, and I think it's interesting to actually really try and let the rubber hit the road on these things and try to get a sense for what do you do with them. It's difficult. It's expensive to set up a fuzzer. That's why again FuzzBuzz was really caught my eye. Mm-hmm. You let that thing run, you let it find what it can. But it sort of comes back to similar to what we've been talking about, both the MITRE attack, now that I think about it, the Matrix, as well as just the results of a pen test. You show those either to another developer and say, hey, look, there's a buzz, the fuzzer found it, I need to fix it, or to management, whatever else. The question comes back of, okay, you threw a machine at this for a week and it found this one little nitty-gritty bug. Is that really worth the time for us to understand how to fix it, or should we actually work about functionality and keep the product growing and keep the customer base happy? And that's this is what's been on my mind the last week or so. How do you deal with this? What do you get as a result of a fuzzing library like this? Or, hey, look, we can fuzz faster. So the fuzz faster definitely useful, but I think it's interesting for folks to think about, not just as these tools get better, but what do you do with the results? And then, at that point, it's like, okay, well, if I can't use the results, do I fuzz in the first place, or what do I do, or how do I rank is there a way to rank the results? So, almost like a CVSS score of the fuzzer found this and it's extremely exploitable versus the fuzzer found this and we never use that code. So it's an interesting space, not just the academics, but what do you do with the results?
And that's a great question, because I think it ties to, at least with a fuzzer, a crash happened. So it can speak to software quality. But, the more important aspect you're getting at is, do we spend a week of CPU resources to find that one issue and fix it that might not even be exploitable? Or is that budget better spent? And again, I really enjoyed our last segment on OWASP Top 10 with Andrew. It also speaks to that idea, should we be playing, fixing one more bug in XSS or one more bug in SQL injection, or investing that time into an ORM or into a React framework or something else that's going to kill a particular bug class. So yeah, I think that there is still, regardless of whether you're using fuzzing, what you're getting at in the sense of, where do I prioritize my budget? And my budget means both money for tooling, as well as that time to set up tooling and the time it takes for developers to respond to it. That's not inconsequential. So I think those are great conversations to have in the sense of, what's the feedback we're getting out of this, and are we getting value? And I'm going to try to use that as a segue into the final article real quick about Slack, and just that idea too, in the sense of, great, we've spent our security budget and we've done our framework changes, and we've done some fuzzing, or we've done some good security design to say we're immune to this particular type of injection attack, or we're using libjpeg, but we have it isolated in its own process, that we're using RPC calls to shuttle data back and forth, and therefore a compromise in libjpeg isn't actually going to expose any user data, which actually is, I want to say, is great design, good things to do. But what this Slack, the article about Slack, the recent response to it, is still highlighting there are other threat models about the user population that are great to mature into. Don't just stop and saying, great, we use this React framework, we use this ORM framework, we use this other framework for CSRF. Our job here as application security is done. There are many other examples to get into of what's the context of how the data is being used. Really dive into the throwaway line of business logic and understand, what does that business logic actually imply for the user population. And so that was my real quick way to try and bring us to at least that comment there, as we're running out of time on that article. But John, let's throw it back to you to see if you'd like any last words to close us out with on either Slack or one of the other topics we hit on so far today.
I'm good. This is, it's, for some reason, just the thought on this one, it's making me, it feels like management from the company Uber went over and took a jog at Slack, right? They were that much more, we're going to slam ahead, and then as we meet resistance from cities, then we'll have to try and work and figure out how to do that. That's sort of the way this felt, right? We're going to put this thing out there, then if people complain about it from a security point of view, then we'll sort of come back and, not knocking Slack. I think we all understand why they did it, but still it's a little more architecture to use. Again, our back to our OWASP conversation, would have been nice to have a little more thought around that user architecture.
Yeah, and I definitely highlight is the idea of educating that there are many more threat models than these. Than just talking about the injection vulnerabilities and the context of where output is being written to. So with that, perhaps we would love to hear on our Discord channel, what are some other articles or some other threat models that have been interesting in your environments? Or do you have some articles? We'd love to talk about more things around how products are being designed in architecture. So send us out, dear listeners, as well as I will say we're going to send ourselves out as we've wrapped up near the end. Want to say thank you to John, thank you to everyone else, and we'll see you next week on Application Security Weekly.